Hey everyone, this is Bathymetrics, and today I'm going to be talking about shaped modulation and global modulation, a good workflow for doing modulation in a single global channel. I'm also going to be covering a weird little bug about a product called Gatekeeper that seems like a lot of people don't know about, and I've never seen documented anywhere when I've Googled for it. So I'm going to be showing you a weird little gotcha with Gatekeeper too. Um, so let me explain what I mean by shaped modulation, just to set the stage for everything. Um, if you look at a synthesizer like Pigments, it has a set of different types of modulators, and one of them they call functions. And you can see that this is like a hand-drawn curve. It's a function curve. Okay, here's a slightly different shape. Here's another shape. So that's a hand-drawn type of automation or modulation rather. Um, of course, there's good old Serum, and its LFO tabs are hand-drawn modulation. You can make any shape you want, right? And then Ableton Live in particular has a specific Max for Live audio effect they call Shaper. And this is why I call it shaped modulation, because I think overall it's a good name for it. This is their shaper device. Come on. So again, like in Serum or Pigments, you can draw certain shapes, add curves, and so on and so forth. And then you can get any kind of shaped modulation you want. So that's what I mean by shape modulation. I'm going to show you a couple ways to do that in Bitwig. It's important to note that Bitwig right now in version 2.4 and even in the upcoming version 2.5, Bitwig does not have a true shaped modulator. They have a modulator that's kind of shaped. I'm going to show it to you briefly. It's called, actually, it's a modulator, so I need to get to this a different way. Now let's just put on any old device. And then let's open up the modulators tab. They call it 4-stage, this one at the top of their list of modulators. This is kind of a shaped modulator. You can draw curved lines, kind of, sort of. They're not very dramatic. You can set, how the envelope is set up. So it's sort of a shaped envelope, but it's really, really hard to work with. Especially if you want to sync it to tempo, you have to do this math in your head to understand, are these quarter notes? Are these 16th notes? Where exactly is each point on the grid? You can see there's no horizontal grid. There's no way to show eighth notes, quarter notes, and so on in your project. So it's really freaking hard to set this up. And if any Bitwig devs are watching this video, please give us a true hand-drawn shaper. This is not adequate. This is not very friendly. It's not easy to create a shaped modulation in here. So there are some things this is good for, but it's definitely not for what most of us think of as quick hand-drawn shaped modulation. I would really love to see something we can draw in directly, similar to Serum, Pigments, LFO Tool, Volume Shaper, Gatekeeper, those kinds of things. So that's my little rant about 4-stage. Okay, so I'm going to try and keep this video as short as possible. I'm going to do a quick run through without going into too much detail for the people that are already familiar with Bitwig and the people that understand a lot of these devices I'm going to be talking about. And then I'll slow down and backtrack a little bit and go into more depth about some of these things. So if at first you're not completely following what I'm talking about, just hang in there for a few more minutes and I'll go back and cover some things in more detail. So I can demonstrate what's happening with a good approach to global modulation and various types of shaped and non-shaped modulation. If you look at this filter device down here, this is on my audio track 3. There's several different types of modulation happening here. You'll notice that the transport isn't running, the playhead's not running. And so I have this free running kind of automation already happening on the filter cutoff. And if you look at the way it's traveling, it's asynchronous, or rather non-symmetrical. So it goes halfway and then it goes all the way, and there's a little bit of bouncing back and forth. That's being done with a shaped modulator. I'll show that in a second. Now this button here, I'm actually controlling by hand with a knob on my MIDI fighter twister. And you'll notice that I can make it a bipolar type of modulation value, and it's static. If I stop twisting the button, it just stays where I put it. Okay, it can go negative, it can go positive, etc. Then if I start the play transport, you're going to see the pre and post buttons both automating. The pre is going to be bipolar from its current setting, and the post button is going to be unipolar from its current setting. So we've got several different types of modulation happening here, and there's nothing else in this Audio 3 track. The modulation is coming from somewhere else. Specifically, it's being done on this track here called Global Modulators, and this trigger MIDI is triggering one of the modulators. Now, why would you want to do global modulators? The basic deal is this. I can't tell you how many times in a project I have gone to a specific track, a specific sound, and I've set up some sort of modulation on it, hand-drawn or otherwise. And then later I decide, you know what, I want to use that same exact modulation envelope on some other sounds in my project. And then I have to remember where I put the first one, and then I have to route it to the other ones. And then it's like, if I put down the project for a few weeks and come back to it and pick it up again, I'm like, where is this modulation coming from? I have to dig through my project to figure it out. Sometimes Bitwig can make it difficult to go find where you're sourcing things from if you don't have a little bit of workflow hygiene and some best practice habits. So I've come around to the conclusion, and this has been based on a lot of discussion with other serious Bitwig users over on the KVR forums. There was a really good discussion thread recently between XBits, a user called Moy, and a user called UUU, that we're all talking about basically global automation and why to do it and what are the best ways to do it. So I did a lot of experimentation based on our long discussion, and I'm going to show you what I think is the best, simplest, cleanest approach to global modulation. And the advantage of global modulation is when you're looking for a modulation source, you want to look in one place for it. So by putting all of your modulation sources on one main track, that can sometimes make it easier to reuse the same modulation envelope on a lot of different things throughout your project, and then still always know where to go find it. So before I show you the global modulators track, let me give you an example of that. If I expand the modulators section for this filter, you can see that all the modulation that's going on here, except for the one manual knob that I'm turning here, these other four, the filter cutoff, the pre and the post, I'm sorry, these other three, they're coming from these three moving audio rate modulators. This is called audio rate. And each one of them, you can see that the source for the modulation signal has a name like Super Macro 2, or here, I'll show you a trick. If you're not aware of this in Bitwig yet, you're not limited to looking at just one modulator at a time. You can hold Shift or Control and multi-select other modulators to pop them all open and see their dialogues. So you can see that this one here is coming from something called Super Macro 1. This one here is coming from Super Macro 2. This one's coming from Super Macro 5. And this one here is coming from Super Macro 6, right? So already I have some very unique identifiers that are kind of telling me what's going on. And that can be a very helpful thing. So let's go look at where the modulation is coming from. You'll notice these are all pulling an audio rate signal from somewhere, a continuous high resolution audio signal of some sort. If we look at the global modulators track, got a few interesting things going on here. We've got this strange FX layer called super macros. It's got a bunch of macro knobs in it. Here's the actual macro knobs right here. It's two of these groups of, the four macro knobs. Some of the knobs are running in a bipolar mode. Some of them are running in a unipolar mode, right? and they're being modulated in different ways. Like this macro here is MIDI mapped. If I go over here to the button in the lower right that shows you your MIDI mapping for the project, you can see on the macro one here and the macro knob here that this is, linked to a hardware controller through MIDI mapping. And then let's turn that mode off so it's not distracting. You can see the little blue dot next to macro 2 here, macro knob 2. And that, whenever you see that blue dot, it means there's track or clip automation that's running that. Okay, so if we expand the global modulator automation lanes to see what's going on there, we can see that here I've got a simple automation ramp that's controlling super macro 2. Okay, so that's where this modulation is coming from. And if we look at this group that has super macro 5 and super macro 6, those are being controlled respectively by these two devices. This one, and I'll explain this in more detail in a second, this CC value, this CC signal on control change 111, this is coming from an LFO tool. And this one here, we blow it out, is coming from Gatekeeper. And this is actually a constant voltage signal coming out of Gatekeeper, which is a neat trick of Gatekeepers. And I'll talk about that in more detail in a second. So these two modulators, if I hover over the assignment button for each one, you can see this is modulating super macro 5 all the way from its lowest value to its highest value in a unipolar way. And again, you can see that super macro 5 is unipolar because button isn't lit up. Now this one here, this audio rate, is automating super macro 6, which is set to a bipolar mode. And if you pay really close attention to this signal here, there's a center line for audio rate, and anything that happens above the center line is a positive signal. Anything that happens below the center line is a negative signal. So just because this thing is hitting the complete top and bottom borders of the audio rate, you can tell that it's actually a bipolar signal that's coming out of Gatekeeper there. Sorry for the system stutters. So this seems a little complex, but I'll backtrack in a minute. Those of you that are used to doing stuff like this will pretty much instantly grok what's happening. And then the other part about this that's very interesting is each of these macro knobs is assigned to a bunch of DC offset devices. Okay, so what's literally being generated out of this super macros rack, if you will, is a bunch of different DC offset signals. And DC offset is interesting because it's normally meant to be used to push your speaker cone in and out. That's pretty much what DC offset is. When this value is above the line, that's a positive value pushing your speaker out. And when the value is below the line, it's a negative value that's pulling your speaker cone backwards. And the main reason DC offset exists in Bitwig is you can modulate this with an LFO, and if you spin it up and down fast enough, you're actually pushing your speaker cone in and out. And as you move up into the audible hertz range, you'll actually generate sound. So this can be used as a basic oscillator. If you're building some custom devices, you can use this as an oscillator, but it also has another advantage in that it's kind of like a control voltage signal. This isn't strictly voltage, but it works like voltage. And so, when it's at the center line, there's no voltage. When it's above the center line, there's a positive voltage. And when it's below the center line, it's a negative voltage. And an audio rate device, an audio rate modulator can pick up that signal and do something with it. Like here's the audio rate modulator that's picking up the signal coming out of super macro 1, which is this DC offset signal. So as I turn my MIDI fighter twister button up, it's a positive signal. So if we come over here and look at what it's doing here, see how the line, now the purple line right here is above the center. And as I twist my twister knob, it goes to center. Now I'm moving up below center. I'm manually modulating that signal, and the audio rate is following that, right? all the way to the bottom, or all the way up to the top. Okay, so audio rate is the trick. Now, the advantage of audio rate and using audio rate as the output of your modulators, right? The thing that everything in your global modulators channel might be sending out. We're doing it through a set of 8 different DC offset devices. So that means all the signals being spit out are a continuous voltage kind of signal, an audio rate signal. Its resolution is probably something like 32-bit float, so it's not at all stepped or staggered. It's a very continuous line. So it's a very fine, high-resolution signal to capture as a modulation source. It's always going to be very, very accurate. By contrast, there are some techniques for using MIDI CC devices to spit out a MIDI CC value from 0 to 127, but the problem with that is the Bitwig device that does MIDI CC. Let's go find it real quick just to show you. It's this device called MIDI CC. You can use this device to send out, oops, damn it. You can use this device to send out a bunch of control signals. Let's find it again. I'm gonna be so glad when 2.5 comes out and I can make that always use any device type. So there's 8 different knobs here, but these are all spitting out MIDI CC, and you can assign which controller channel to use, and it's just sending out a value from 127 to 0. And it looks like it's sending out interpolated values, like it's not just going from 0 to 1 to 2 to 3. It's got all these decimal points in between. But for whatever reason, if you try to pick up this signal on the other side with a MIDI modulator, the result is very stepped. It's really jaggy looking. It's like doink, 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 doink. It's not a smooth value like this DC offset value. So I don't know why that is, because it sure looks like it's spitting out interpolated values, but in fact, it doesn't really. So I would recommend not using a MIDI approach to setting up a modulator signals you can pick up elsewhere in the project. I recommend using this technique that you came up with, which is based on these DC offsets. So hang on if you still don't really understand this. I'm going to go in a few more minutes. I'll come back here and show you how to build this. I'll also point out that I've already built this for you. If you don't want to have to think about building it yourself, I have over here, I've got a version of this Super 8 modulator that's already set up with good labels and ready to go, ready to use with the DC offsets. So you can just grab this from, I'll put some links in the description for this video. So if you don't want to have to build this, you don't have to build it. But I'll describe how to do it in a minute in case you want to build it yourself. Likewise, I'm going to be talking about the 2 shaped techniques I'm using now, which is Gatekeeper and, where are you, Gatekeeper? There you are. LFO Tool. These are 2 different modulation sources I'm using for the shaped modulation in this whole thing. LFO Tool is modulating Super Macro 5. And Gatekeeper here, this envelope in Gatekeeper is modulating Super Macro 6 in a bipolar way. So these require some careful setup to work correctly as modulators rather than just simple volume manipulators on an audio signal running through them. So I also have predefined versions of these 2. So if you have Gatekeeper or you have LFO Tool, you'll be able to grab this preset I made for LFO Tool that's already configured the right way, or you can grab this preset for Gatekeeper that I've already configured the right way and put inside a container and done some things you have to do to use Gatekeeper successfully. So I'll be talking about all that in a minute, but just letting you know, if you don't want to build this yourself, look down below in the, come on, go away. Look down below in, the hell? Oh, yes. There we go. Yeah. Okay. Yes. Yes, go away. Thank you. All right, we're back to normal. Fortunately, Bitwig is pretty robust about um, recovering from crashes of various sorts. In this case, it recovered automatically. I didn't have to do a thing. So let's stop this stuff for a minute and let's go over and talk a little bit about a thing you really need to know about Gatekeeper. And let me think for a minute. No, I'll show you that in a second. For people that don't know about this bug, I want to make a special timestamp link to it so I can show it to them, because I've had people say Gatekeeper doesn't have a bug, but it does, and I'm going to demonstrate that a little bit later. Okay, so let's just talk a little bit about how I'm using the two shapers to overcome Bitwig's lack of an actual hand-drawn modulation shaper of any sort. Of the two, LFO Tool is usable, but it's got a lot of downsides. It's hard to work with, and it's hard to work with in a variety of ways, but you can use it as a modulation signal, just like you see me doing here. This is currently modulating Super Macro 5 in this way. And then because I'm modulating Super Macro 5 and it's creating a DC offset signal that matches, then over here in the target audio track, Super Macro 5, which is right here, this one, just narrow it down to this one, you can see it's outputting a control signal that's just picking up the same exact shape that's coming through the DC offset that LFO Tool is driving over on the global modulator channel. So, you know, I'm not linked here to LFO Tool itself. I'm linked to the DC offset that LFO Tool is modulating over in that Super 8 rack on the global modulators channel. So the way that looks is, and this is why it's so easy to set up this way. I go to global modulators, I say, show me my super macro chains. Every one of the super macro chains ends in an audio signal that's coming from that DC offset. So I just say, pick Super Macro 5's pre-fader output. Okay. So if I grab that, it's grabbing Super Macro 5, it's reading that DC offset value and just making the same exact shape that's in LFO Tool itself. Okay, that's the basic idea here. So LFO Tool has quite a few problems. You can make it work, but it's tricky. The first thing is LFO Tool, if you're using it as a modulator, you have to configure it to spit out a MIDI CC value. Unfortunately, LFO Tool does kick out a interpolated, fairly high resolution set of MIDI CC signals. It's not just going from 0 to 1 to 2 to 3 when it follows this curve. It's using a lot of decimal points in between each integer number from 0 to 127. But you do have to configure it to use a specific CC number, and every LFO tool you might put in the project has to use a different CC number, or they might clash with each other to some degree. You also have to set the cutoff to 100% over here, and you have to set the volume back to 0, because by default LFO Tool is only trying to modulate the volume. So you have to remember to set this to 0, this to 100. You have to set this cutoff all the way to 0, because by default it's midway. It's a little funky to work with in terms of configuring it. Not too bad, but there's a lot of things you have to remember. The other problem with LFO Tool is by default it's a completely bipolar signal. So to get a unipolar signal out of it, you have to always work from the center up. If I drag these two endpoints downward, this is now spitting out a bipolar signal. Positive is this half, negative is this half. And the problem is, that would be great, except the problem is the thing that you tap a MIDI CC signal with is called, it's a modulator called, I'm just going to pull it up here, show you. It's the modulator called MIDI right here. And MIDI by default is set up to listen to all MIDI channels and listen for a CC message on a particular CC channel. So if I were to set this to listen to channel 1 and CC 111 to match what this LFO tool is kicking out, everything looks good, right? But here's the problem. Look at this signal right here. Just watch this yellow line. And also, why aren't you actually giving me a signal? You should be giving me a signal now. Oh, because I, well, that's the other thing. So this is listening to CC111, but there's no MIDI signal flowing into this insert track for audio 3 yet. There's no MIDI signal running through here. You don't see any yellow dots up in these sides. So to get LFO Tool to work as a direct kind of tap like this, where I'm tapping into CC111, I also have to drop in here an audio, I'm sorry, a note receiver. Oops, if I spell it right. I have to drop in this kind of patch cable and say, pick up the MIDI signal that's coming out of the global modulator channel. Okay, so now I'm routing MIDI signal that's coming out of global modulator, which is where this LFO tool actually lives. This one right here, it's sitting on this channel. So it's kicking out MIDI on CC11, but only in this channel. So I use this to yank it over into this channel, this note receiver. So now you can see the CC value is matching the curve of the LFO shape itself, but check this out. I'm gonna move this all the way up to the center. So now the shape you see here with yellow matches the timing and shape of this. Let me speed it up just a little bit, make it a shorter signal so the blips are a little closer together. All right, set it up like that. So see how this yellow signal completely matches the shape you see here. Now I want you to watch what happens to the bottom points of this yellow signal. See how they're nice and sharp to match the sharpness of this dot right here, for example. Nice and sharp. As I move this into a bipolar mode by pulling these endpoints down below 0, see how we start getting a gap? See how there's this little horizontal gap where this part of the curve is happening? There's a little gap there. See that flat line at the bottom? So it can be really confusing to work with a bipolar signal because if you go below the center line, you're not going to get the actual shape down here that matches the shape your brain sees when you look at this. There's like this weird extra step where the CC modulator only hears or sees a unipolar signal. It doesn't know what to do with any part of the signal that drops below the midline in LFO Tool, and so it just gives you a big blank line there. Okay, so that can really mess you up when you're trying to figure out why isn't my modulation working the way I expect it to. So that would be okay if we could snap these endpoints to 0, but unfortunately LFO Tool will let you snap, like if I've got the grid size here set to 8, I can snap. Hey, why aren't you snapping? Should be able to snap those. What's going on? What's going on? What's going on? What's going on? Been a while since I messed with LFO Tool. There's probably a control key I can pick to make it snap. What is it? No, it's not control, not shift. Well, shit, I don't know. And now I've done something by turning it red. But either way, LFO Tool's hard to work with. It's hard to snap things on the vertical scale. So it's hard to get these little lines exactly at 0. And depending on how specific you're trying to get with your modulation, it can just mess you up bad. So what else is wrong with LFO Tool? You're kind of limited in the total number of these you can have in your project because there's only so many unassigned MIDI CC values. And like I said, every instance of LFO Tool has to have a unique MIDI CC value. And it can be really hard to trace backward from some place you're modulating from. Like if I'm down here in a track and I can see that I've got this modulator coming in and I'm like, where does this come from? The only information I have is that it's on CC111. That's the only unique identifier in this entire modulator setup, right? Now compare that to, and I'm just going to get rid of this now because we don't need it anymore. Compare this to an audio rate signal where, you know, For an audio rate to work, it's kind of like you have this side chain input into it, or you can say, don't use a side chain input, just pull in whatever is running through the audio in this insert chain. That's what no device input is. It's just saying take whatever audio is moving through and use that to manipulate the audio rate up and down. But you can sidechain, and it's very easy to figure out where the sidechain is coming from. Let's see, this is number 6. Okay, so this one here is coming from something called Super Macro 6, and that gives me a lot more clues if you have a good naming conventions for where this original signal is coming from. Makes it a lot easier to trace it back. So again, like I was showing you earlier, every one of these audio rate modulators, I can see exactly what the name of the originating signal is. And that can give me a clue to go find it. Like if I know all my super macros are living on a track I call global modulators, and they're in a device called super macros, well, hey, that's super easy. Now I've just found my modulation source. Okay, so all of these things just point to some reasons why LFO tool is a little tricky to work with. You can make it work, but I don't recommend it. If instead you have Gatekeeper by Polyverse, this is actually a much easier modulator to work with in some ways. So there are a few tricks you have to remember for using it successfully, but the tricks are pretty easy to keep straight. The first trick is that Gatekeeper by default is just meant to process audio that flows through it. You know, you got it on a super saw and you want to make it flutter, or you have a ducking type curve shape in here that might look like something like this, typical drum ducking shape. Right, maybe you get fancy and do something like this to give it a little bit of a envelope at the beginning, a nice smooth little drop into 0, right? So this is a typical type of drum ducking shape. And normally it's meant to have audio signal just flowing through at 100%, and then you kick out the volume to make your ducking, right? Or it's on a super saw with a, you know, some interesting shape, like one of the preset shapes in here, and it just makes the volume flutter in interesting ways. Okay, so by default, Gatekeeper wants to just process audio that flows through it. But Gatekeeper also has this cool CV output mode. And what's cool is the output signal can be unipolar or bipolar. And now it's just kicking out a constant voltage, a lot like these DC offsets will kick out a constant voltage. And when you set up Gatekeeper to use CV unipolar or bipolar, you can use it as a control signal to modulate other things, and it's great for that. There are a couple gotchas with Gatekeeper. The first gotcha is that, number one, when it's putting out CV signal, it's actually putting out audio. So if you look really closely here at this FX layer that has a shaper, one channel that I've named shaper GK1, and inside that channel is a note receiver followed, which is what's picking up, by the way, the trigger notes on this MIDI clip. It's got a note receiver and then the Gatekeeper itself. And you can see that the Gatekeeper inside the boundary of the blue inner channel for this, it's actually putting out an audio signal. Well, you don't necessarily want that flowing through the rest of your chain. You want to sort of like block that signal. So it just stays inside this little box, and you can just tap into the box in the way you want to. You don't want the signal flowing through the rest of your signal chain. Like, look at these super macros that aren't being used, these channels 7, 8, and 3 and 4. If I turn up the mix on the container that Gatekeeper is inside of, you're going to see that they start outputting volume, and you can actually hear that clicking. Boom, boom. That's happening every time Gatekeeper is re-triggering its envelope. Let's actually open up Gatekeeper and show you. Okay, every time it pops down to 0 from maximum volume, it's boom, you're hearing a click, right? Well, you don't want that. If you're using this as a control signal, you want to stop that sound from actually flowing anywhere, because it's this very abrupt signal change from the CV voltage. So A simple trick for managing Gatekeeper is to put it inside of any kind of Bitwig container device that has a mix knob, because if mix is 0, nothing escapes, right? No sound actually escapes. Gatekeeper's signal is confined to the box. So that's why it's inside of this FX layer device. And again, I've already set this up for you in this pre-built device right here called Shaper GK. And it's already got one channel in it. It's already set to mix of 0, so no sound comes out, and the Gatekeeper is ready to go and has a unique name to it, unique name, and so on. So again, if you have Gatekeeper, you can just grab this link from the video description and use it as is, and you don't necessarily have to set it up. But that's just a thing to know about Gatekeeper. If you use it as a modulator, you have to somehow block its actual audio signal so that you're only using it as a modulation source. Now, the other bug about Gatekeeper, the other funky thing is there's an actual bug in Gatekeeper. And I've had people argue with me saying it doesn't exist, but I'm going to show you that bug right now. To do that, I'm going to stop playback here, and we're going to flip over to another project where I can demonstrate the bug really easily. Okay, so what I've got here is Gatekeeper used in its most typical sense, that most of us use it as like a ducking curve for kick drums and snare drums and whatever. And it's triggered by MIDI. So what I have here, I'm in this first track called Gatekeeper Ducking. There's 2 MIDI signals coming through here. They're both 16th notes on a 2-bar clip. So I'm sorry, a 1-bar clip. So there's one 16th note here. There's another 16th note here. If this was a normal time drum track, these would be the downbeats of the drum track in normal time. So we want Gatekeeper to duck out whatever audio it's processing each time the kick note hits, right? So the kick starts right here, and it starts again right here. And every time it starts, we want Gatekeeper to run this envelope once. So this is a typical ducking scenario. So what I'm doing to show you what the ducking looks like and to help demonstrate the bug with Gatekeeper is I'm just running a white noise generator. So this is just a solid bar of white noise happening right now. And I'm blocking it currently with unfortunately, Bitwig's tool device doesn't go all the way down to negative infinity. So until they catch up with Ableton that way and make it go to negative infinity, I have to use a different kind of utility plugin from Melda Productions called M-Utility. This one's great because it goes all the way down to negative infinity. It doesn't just stop at negative 36. So I'm just using it as a sound block for the white noise right now. If I turn it on, you're going to hear some hiss. Okay, so your sidechain group or a specific synthesizer sound or your sub or whatever is running through Gatekeeper in this scenario. Gatekeeper is just sitting right in the middle and it's going to do its thing. Gatekeeper is set up to listen for MIDI notes, right? Any MIDI note that rolls through it is just going to trigger the envelope each time. So here's what a typical ducking curve looks like, right? You can see it's ducking out every time the MIDI note happens. So far, so good, right? No problems, no bugs with Gatekeeper. This is what it sounds like. Okay, so far, so good. The problem is Gatekeeper's only working correctly because of the way there's this very beginning section is set up. There's a bug with Gatekeeper, and it's an easy bug to run into. Not so much if you grab a pre-built ducking curve that looks like this, where this starts with full volume, ducks out, and comes back and stops at full volume, right? So that when the envelope triggers and runs and then stops, everything's still at full volume. These two controls are linked, like you see here. And if I drag it all the way to the bottom, we're stopping everything that comes through. That's why ducking curves don't look like this. They start at full volume. okay? And then when the envelope triggers, it ducks. So the problem is you can draw this in a different way. If I get rid of this point entirely and I start the shape like this, well, that doesn't look right, right? That's not ducking because there's no sound at all happening. The sound will actually happen when I'm running the curve, and it's only going to happen for this portion of the curve that's at full volume. So you never hear this problem when you're ducking, because a ducking curve never looks like this. A ducking curve always looks more like this, okay? And so full volume, problem never happens. But here's where the problem happens. I'm going to go to a different version of Gatekeeper. This time I'm using it as a modulator. So here's my little FX layer with the Gatekeeper in it. And there's one instance of Gatekeeper in it. And then the Gatekeeper here is putting out, instead of processing audio that's running through, it's putting out a unipolar CV signal, right? So when this one gets triggered by the same exact MIDI notes with the same exact ducking shape, everything looks fine again. And the ducking, by the way, is simply modulating, from Gatekeeper out. I'm pulling the CV out and I'm modulating the volume from 0 to 100 of this Melody utility. So if I pop this open, you'll see it. You'll see this knob moving around as I run the curve. See how it ducks briefly and then comes back to full to match what's happening in the curve here. So this is, the same exact ducking shape, the same exact ducking behavior, just done a different way. Now it's being done as a modulator, modulating the volume rather than just Gatekeeper directly affecting the audio that passes through it. But the shape's the same. You see how it's working perfectly. Now here's the problem. Here's the problem with Gatekeeper. If I get rid of this, actually, let's do it this way. I'm going to get rid of you, drag you down, set the curve to look more like a ducking curve. Something like this. No, that's not a good way to show you. Sorry, I did practice this, I really did. Let's get rid of all these. Let's just start at the bottom. I'll just show you from here. So what we have here, if I get rid of all nodes, and it's just the two start and end modes, it's literally like a volume control. No signal, full signal, and everything in between, right? If I start here and I ramp, see, I can't ramp the signal down because it's all one thing. I have to create some sort of extra point and ramp it down that way. So now I have what looks like a simple saw wave shape. And if I start modulating this, we get some weird behavior. That was weird. Did you see that little blip? Let's manually automate it. With Gatekeeper, if you click this, it just free runs. And this looks normal. This is the kind of shape we would expect to see on the white noise. It's going from full to 0, back to full to 0, and it's just rolling through on the basis of a half note at a time, okay? So everything's fine. If I start my play transport, all that does is, you're gonna watch, I'll start it when the signal hits about this point, and it just resyncs from the beginning, and now it's locked my clock tempo, right? So it free runs unless the transport's running, but as soon as you run the transport, it gets completely synced to your playback grid. Boom. So it just synced, and now it's 100% synced with my playback grid. If I set the starting point of the grid to be like, this midway point, and I start it, you'll see every time I start and stop transport, it's going to start from this midway point. Start. See how it started right from the center? Stop. Start. What? Start. See how it jumped to the center? So it locks to your grid when you have, stop that, when you have this button pressed. Okay, so everything looks good when you're working from free running mode or from tempo synced, clock synced mode. These shapes look normal. They look like what you'd expect, right? If I flip this to a different pattern, like I move this down here, and then this all the way up here. We get the same exact behavior. Everything looks the way we would expect it to, right? Curve this, the curve becomes more shaped. Curve it this way, it becomes more shaped that way, but everything lines up and overlaps correctly, right? But watch what happens if I try to trigger this. Let's go back to a simple straight curve. Let's just get rid of you and set you up again. Watch what happens when, instead of triggering this from the transport or the clock, I trigger it from notes. When you turn off this play button, Gatekeeper will just wait for incoming MIDI notes to trigger it. And at the note on, it just triggers the envelope one time. So watch what happens now. That looked good. That looked, what? Wait, what? What's that weird curvature happening at the end? What is that? Okay, now again, if I stop it from listening to MIDI notes and I let it trigger just according to the clock, you're going to see that there are all these perfect flat drop-offs like we have drawn on the envelope. Okay, that's a frickin' bug. Look at this again. I'm going to turn it off and let it trigger from the MIDI notes again. First one looks okay. That's bad. That's bad. That's bad. That's bad. And that's bad, and that's bad, and that's bad, and that's bad, and so on. But oh, wait, there was a good one that just rolled by. What the hell? Some of them are, a lot of them are bad, and one of them is good and actually matches the envelope shape. There's something really weird going on here, right? And you can really see it if we go in the other direction with a ramp. Let's drop you down, get you up here. Okay, so now we're starting the other way from a full signal, and we're going to cut it down. Okay, whoops, what the hell is that? What's that? What's that? No, it should look like this. Okay, so something about MIDI triggered Gatekeeper envelopes can get fucked up really badly. Here we're going to go back to triggering it from MIDI notes again. It's just completely screwed up. This is not what we expect at all. There's some weird smoothing behavior that's fucking up the turnaround of this envelope. Now, there's a couple ways to fix it, but you shouldn't have to fix it. There's some ways to jiggle it and make it work right. Like if I move this bottom point just slightly off the node, they'll start looking a little bit better, right? They're not having quite that same degree of roundedness, but still, it's not the shape I want. I've got this, starting slope to what's going on there. And sometimes there's still a perfectly flat slope anyway. No, it's always going to match. It's when the endpoints of your envelope start and stop completely at where the note ons are happening that you'll run into this weird behavior like this. You're not going to run into it in normal ducking usage, but you will run into it with constant voltage usage. Now, it turns out, for whatever reason, there's a really simple fix. The simple fix to remember to get around this bug is to simply make sure that your very first point in the envelope isn't a single point like this. Instead, you want to create one more point, drag it over to the start of the envelope, and just make sure that's the point you're using. Now with this extra point flipped right over and snapped to the edge, if I drag it up here on top of the real starting point, it's just like one little envelope move to here, and instead of being over here somewhere, it's just snapped up and even covering up the original envelope point. Now, when I run this in a MIDI triggered mode, it's going to be perfect. So these are the MIDI notes triggering it, and it's exactly what we would expect, perfectly shaped, exactly the same as if it weren't being triggered with MIDI notes and was instead being triggered with the clock. So why Gatekeeper works this way, I don't know. I think it's an outright bug. I've looked for updates or anyone else pointing out this bug, and I haven't been able to find it. So the thing to remember to get Gatekeeper to work right is basically always make sure the start of your envelope is 2 points, right? I mean, you'd normally have that anyway if you wanted an envelope shape that looked like this, right? You'd have 2 points anyway. But even if you want it to start right at the very beginning, just make sure you've got 2 points. And it doesn't really matter where this one sits, except it controls whether you're starting from full volume or no volume. Okay, so hopefully that makes sense. I just wanted to point out that bug. And it's just a thing to remember when you're using Gatekeeper. Always start with 2 points. Doesn't matter what you end with, it matters what you start with over here. And again, it's only a problem or a bug when this is turned off and you're triggering Gatekeeper with MIDI notes. So just really burn that into your brain if you're using Gatekeeper as a modulator. Now, aside from that weird little thing, it's really nice to use Gatekeeper because it can spit out a unipolar or bipolar signal, and we can do fun things with that. So going back to the Super Modulators project, let's reactivate that. And let me just show you one last thing about this. How to actually set up the super macros and how to set up Gatekeeper and LFO Tool. I'm just going to run through that super quick for people that want to build it themselves, don't want to grab my stuff. So let's close this track up and let's just create a new MIDI track. All right, so to create the Super 8 device, the thing that looks like this, I'm just going to leave this here for reference, show you everything that's in it by default. Now I'll show you how to set it up by hand. So we start with a FX layer device. And the reason we use FX layer is because we are also going to turn the mix all the way to -100, and we're going to have multiple channels in it. And remember, these DC modulators, these DC offsets, are actually putting out an audio signal. You know, if you look here, there's audio signal coming through some of these channels, and you want to block it. You don't want that audio signal actually going anywhere, and you don't want to have to mute the track and remember to keep the track muted and all that crap. So the easy way to take care of that is to just set the mix to 0. Then create a channel and drop in a DC offset. Oops. Again, it helps if I can spell. And I recommend that you name the channel so that it makes sense and you can keep it straight. So Super Macro 1, right? And it's got a DC offset in it. And then the next thing you're going to do is duplicate this 7 times. 1, 2, 3, 4, 5, 6, 7, so that we have 8 channels. Each one of them has a DC offset, a different one. You'd want to come through and rename these 1 to 8. So like here, 2, and so on. All right. And then you need to hook up something to control and modulate these DC offsets. So we're going to open up the remote control panel, and we're going to drop in a macro 4, which is just 4 macro knobs. It's just 4 of these in a group. So it's useful when you're setting up lots of macro knobs. We're actually going to drop in 2 of those. So another macro 4. And then you start with the first group. And what I recommend is naming each knob, because this is what helps you backtrack later and figure out where a modulation source is coming from. So I like to use Super M1, and then double click here, and Super M2, and so on. Okay, so you get these knobs all named. And then the last thing to do is use each one of these modulation mapping arrows. You're going to modulate the corresponding DC offset in the corresponding channel. So like this arrow is modulating this DC offset. This arrow for Super Macro 2 is modulating the one in Super Macro 2, channel 2, and so on. So again, it's very easy. Just go to channel 1, grab your first arrow. Whoops, make sure channel 1's open. So the arrow's blinking, come here to DC offset and just push it part of the way up. Just move it positive and then drop it. Don't try and make it perfect. Come to the next one, go to the next channel, modulate that one up, go to the next one, next channel, modulate that up, go to the next channel, and modulate that one up. Oops, wrong one. Ha ha ha. Let's clear that assignment. Got to keep it straight. This one here is going to go to the 4th channel. All right, we'll modulate that one up. Okay, so once you've done all 4 in a given block, just turn off your blinky arrows. Come over here to the inspector and just set all these values. Crap, I missed one in there, didn't I? Let's get rid of you. 1, 2, 3, 4. I missed super macro 2, 2, 2, 2. This is why it's helpful to name them. It helps you keep it all straighter. Okay, there's super macro 2 and boom. Okay, so you should have 1 for each of your channels, and you just want to double click these values and set them to 1, just across the board. That's the easy way to do it. What 1 means is exactly to the top of the DC curve. You can actually go above the top, which isn't a good thing. I recommend you set them to 1. And so now, if I twiddle this knob for super macro 1, you're going to see the DC offset go all the way to the top or back to center. It's a positive unipolar value by default. Okay. And then we're going to do one more step, which is to just make it easier to get to these macro knobs by expanding the remote control panel. Click the little wrench, create a new empty preset page just for this one instance of the preset. And you can stop the wrench and just come over here and assign each one of these slots to each one of the super macro knobs as you go through. Right? And they'll automatically pick up the label that you put for the knob. So that's why you label these first. Then the labels just automatically show up here. Okay. And so, now if you modulate the corresponding knob, you can see the DC offset moving. Super macro 2, there's the DC offset moving, and so on. And then the last thing you have to do, very important, is remember that if you want to set any of these to a bipolar mode, it's very easy. You just come to the appropriate super macro knob and switch it to bipolar mode. And it also changes over here in the remote control, so you can tell it's bipolar. And now if I pull it negative, the DC offset signal goes negative. If I push it positive, it goes positive, and it's already constrained to the full range in either negative or positive direction. So that's how you get a bipolar signal if you want it. By default, I just leave them all unipolar because it's not as often that I want a bipolar signal. Okay, so that's how you set up this super macro layer. And then you can come over here and rename it something like super macros or super 8 or whatever you want to call it. And then you can right click and save it as a preset to your library and give it descriptions and all kinds of stuff, right? So if you want to build it yourself, that's how you do this one. And again, this is just kicking out a control voltage signal you can pick up anywhere else in the project with an audio rate, and you can modulate these any way you want. Like I could add an LFO modulator here and assign this LFO to macro 1, and now macro 1 is being modulated by this LFO, right? Or you can go to your global MIDI mapping, and I'm going to twiddle another dial on my I'm gonna click this macro 2 to get it ready to pick up movement, and now I'm twiddling a different dial on my MIDI fighter twister, and then I come back to MIDI mapping, and now wait, did I not accept you? Come here. Yeah, you're there. Why aren't you actually working? Oh, now you're working. Okay, so I turn this off. And now I've got manual control of this one. Or again, you can drop in LFO Tool or Gatekeeper and set up something like an audio rate to pick up the signal from your Gatekeeper, wherever it is, right? Just say, go find my Gatekeeper, pull that audio rate coming out of Gatekeeper, and then I could assign that to a different knob and so on. So the point is, you can line up all of your stuff, all of your shapers or your internal LFO based automation or steps automation or whatever. You can do it all inside this one track. It's all feeding into a single super macro thing, and it's just modulating the super macro knobs. And then over elsewhere in the project, you just pick up the value of any one of these super macro knobs, right? It's any one of these super macro channels. And so again, if I'm over here on something where I'm actually trying to pull a signal from, you just say, okay, go to my global modulators channel, find my set of chains that are in that super macro rack, and then just pick which one of the outputs I want. So super macro 1 pre, super macro 2 pre, and so on. I always recommend using the pre signal. That's just the easiest. And it's as simple as that. So thanks for hanging with me. I'll see you in the next video. Bye-bye.